Okay, the important thing about this complex numbers is the only difference is that we define I squared to be -1, and we define I, so we define the imaginary unit I as I equals the square root of -1, where then I squared equals -1. Okay, so all we have to do is remember that square root of -1 is I, and anytime we get an I squared when we do something, that's going to end up being -1, and then we treat I as a variable besides that. So here, if we want to take the square root of -36, we write this as the square root of -1 times the square root of -36, or positive 36, sorry. And we get 6I, this part. You get 6I. You can check what is 6I squared. To square two things, you square the 6 and you square the I, you get 36 times -1, you get -36. Okay, the next part, we've got real numbers. We got complex numbers. Okay, so before we introduced complex numbers, we only knew about reals. In reals, we had rational numbers and irrational. These were like the square root of 2 and pi, things like that, because they weren't repeating decimals. Rational numbers are any numbers that can be written as a fraction. So 7/3 is a rational number, but also you can write 0/1, so 0 is a rational number. So pretty much the rationals then divide up into whole numbers and integers and anyway, but that's the real numbers. So you know, we have, so anyway, now we're on, if this, we added a category. We call them complex numbers. And these can be, anyway, these can be, and we'll talk about them in this set down here. We can have a pure imaginary number. We can have a complex part and an imaginary part. So these are all in the form of A plus B I. So if A is 0, we have a pure imaginary number. Any number A plus B I is called an imaginary number. Now if B equals 0, we're over in the reals. Okay? So pure imaginary number is just bi. This is a equals 0. So these are all in the complex numbers. So, and we're going to call, so these are called complex numbers and imaginary. So we sometimes we'll interchange what these are called. We can call them imaginary numbers, or complex numbers. So here's what that. So this part said if b is not equal to 0, you got imaginary numbers. If a equals 0, so pure imaginary numbers, and these are go under there. Anyway, so if we fill in, that's the complex numbers. So if we fill in this stuff, the complex numbers, the set of all numbers in the form of a plus bi with real numbers a and b, and I, the imaginary unit, is called the set of complex numbers. The real number a is called the real part. It's really imaginative here. It's called the real part, and the real number b is called the imaginary part. Of the complex number a plus bi. If b is not equal to 0, then the complex number is called an imaginary number. An imaginary number, okay, wait a minute, I drew this wrong. If a equals 0, then it's called a pure imaginary number. Okay, so reading, I just realized I have written this wrong. So we got complex numbers. As long as b is not equal to 0, it's called an imaginary number. And then if a equals 0, it's a pure imaginary number. So, okay, so an imaginary number in the form bi is called a pure imaginary number. Okay, a complex number is said to be simplified if it is expressed in the standard form a plus bi. So here's some examples. If you have minus 4 plus 6i, that's a complex number, and because b is not equal to 0, it's also an imaginary number. So it's complex number, and it's an imaginary number. But it's not pure imaginary because a is not 0. Okay, if you have just the number 2i, that equals 0 plus 2i. This is a pure imaginary number. It's also a complex number and an imaginary number. It's going down. If you have the number 3, that's just a real number. Okay, so equality of complex numbers. If a plus bi equals c plus di, if and only if a equals c and b equals d. This is the real parts are equal. and the imaginary parts are equal. Okay? The real parts are equal and the imaginary parts are equal. That makes sense, right? They can only be equal. The real parts are equal and their imaginary parts are equal. And if the real parts are the if and only if means it goes the other way. If the real parts are equal and the imaginary parts are equal, then they're equal. So. All right. So, next page, sum of complex numbers. Just treat the complex, just treat I like a variable. You already know how to add a plus bx, right? Plus c plus dx. It's the same thing. You don't have to memorize this. Just treat these, just add your like terms. You got a 2 and a 1, that's 3. You got a minus 12i plus a 6i, that is minus 6i. Okay, treat I like a variable. Adding complex numbers. You just treat I like a variable. Next one. 4 plus a negative 8 is negative 4. You add the real parts, add the imaginary parts. 5 plus 2 is 7. That's the answer. All right, how do you do a difference of complex numbers? I don't think you should memorize this right here. Don't memorize this. Just distribute your negative sign. So you have minus 8 plus 4i minus 2 plus 2i, and then combine your like terms. Minus 8 plus minus 2 is minus 10, and 4i plus 2i is 6i. And that's your answer. So we're going to distribute our negative sign and then combine our like terms. All right, next one. Distribute your negative sign. That changes the sign at every term here. 3 plus I plus 1 plus 4i. Combine your like terms. 3 plus 1 is 4. 1i plus 4i is 5i. Okay? Okay, how are we going to do the product of complex numbers? You're going to FOIL. You're going to multiply these things. If it's a binomial, here you're going to just distribute. And then you check if you have an I squared, remember that equals negative 1. If you get an I squared, you'll replace it with negative 1 and simplify. So 4i times 3 is 12i, and 4i minus 4i times 2i is 8i squared. So we got an I squared, so we replace the I squared with minus 1. Negative 8 times minus 1 is plus 8. 12i plus 8. And remember, we really want to write it in the form a plus bi. So we want to write the real part first. 8 plus 12i. I'm not going to take off on the test if you don't switch it around, but it's best to switch it. You want to write it in a plus bi form, standard form. All right. So this is just like distributing with variables, except that I squared equals negative 1. So the next example, we're going to FOIL. First is 5 times 2 is 10. Then the outer term is minus 5i. The inner term is plus 6i. And then 3i times minus I is minus 3i squared. Well, our I squared, this equals -1. So -3 times -1 is +3. Oh, it disappeared on us. Okay. +3. So we have, and I'm going to combine these to -5 plus 6 is +1i, or just an I, +3. So it's going to be 13 plus I. We had a +3 over here. Let's make sure I'm check my work. Yep. Okay. The next thing, it is possible to multiply imaginary numbers and obtain a real number. This occurs when we multiply a plus bi times a minus bi. And again, I hope you all know FOIL, but I'll write it out. It's a times a plus the two outer terms, a times bi. Whoops, there's a negative there. The inner term, a times bi. And the last term is bi times negative bi. So it's a squared minus abi plus abi minus b squared I squared. Anytime you get an I squared, that's -1. And minus AB times I plus AB times I, that'll be 0. If you have minus 4I plus 4I, for instance, or if you have 4 minus 4, say you didn't have an I in there, or minus 4 is 0. That's why those, it's because they're opposite signs. Anytime you have plus or minus in the same things here, you're going to get middle, the inner and outer terms will cancel. And then you have, so you have a squared, and this minus sign went with that. So you have a squared plus b squared. Now to save you a lot of work, you should memorize this. Or if you FOIL it enough, you know, you'll understand, or you'll memorize it if you FOIL it enough, maybe. But it's easier to memorize that. That's not too bad. The only difference, you know, when we had a difference of perfect squares, the reason this is a plus sign here is because this is the sum of perfect squares because we have imaginary numbers. So if we were using imaginary numbers, we could factor a sum of perfect squares. But remember, a difference of perfect squares, how it factors. But anyway, it'll save you a lot of work to remember that this, anything that looks like this with i's in it, is a squared plus b squared. And just to memorize that. Okay. Okay, well, we call that we call it the conjugate of a complex number. The complex conjugate. Of the number a plus bi is a minus bi. Notice there's no negative sign in front of the a, it's in between. So we want to write the real part and then the imaginary part. And just change the sign between them to come up with a conjugate. The complex conjugate of a minus bi is a plus bi. And the multiplication of complex conjugates gives a real number. So if you were to take a plus bi, we just did this, times a minus bi, you will get a squared plus b squared. If you switch the order, a minus bi and a plus bi, you still get the same thing. Doesn't matter if you switch the order. You could FOIL that out and see you get a squared plus b squared. Do you see any i's in that? No. So it's a real number. So that's why we use complex conjugates when we divide complex numbers. Here's the steps to divide a complex number. If we're going to divide, and we have to put parentheses around these, we're going to divide this by this. We don't consider it simplified. We have to get rid of the complex number in the denominator. Okay? In order to do that, we will multiply the denominator by the complex conjugate of the denominator. It's 2 plus 3i, we'll multiply by 2 minus 3i. Well, if we multiply the bottom of a fraction by something, what do we have to multiply the top of it by? The same things, so that we don't change, we just change the look of the fraction. Anything over itself is 1, so we're just changing the look of this fraction rather than the value of it. So that's how you do this. So you go ahead and you have to so this is what the steps say. Multiply the numerator and the denominator by the complex conjugate of the denominator. We're going to FOIL in the numerator, and we're going to remember that the bottom part equals a squared plus b squared. That's going to be easier. So we FOIL this. It's 1 times 2 is 2. 1 times negative 3i is minus 3i. Minus 2i times 2 is minus 4i. Minus 2i times minus 3i is plus 6i squared. Then we're going to divide by 2 squared plus 3 squared. You could FOIL that out, but it's just a lot more work. It's easier to memorize that. You're just going to take the 2 and square it and add the 3 squared. So you get, of course, this is negative 1 here. Then when you multiply 6 by negative 1, you get minus 6. So you're going to combine like terms. So you get your 2 and your negative 6 becomes negative 4. And your negative 3i and your negative 4i is negative 7i. And you're going to divide by 4 plus 9. Divide by 13. So I just kind of skipped a lot of writing. And then you can separate that. If I skip too many steps, let me know. I can show you the one where I didn't skip so many steps. But I did the work up there. I squared is negative 1, and then I multiplied that by the 6 and got negative 6. Negative 6 plus 2 is negative 4. So that's how you do it. That's how you divide complex numbers. And here's the steps right here. All right, another example. So you need to multiply by the conjugate of this. The conjugate of 4 minus I is 4 plus I, not negative 4 plus I. So remember, we just changed the sign. Why? Because if you put the negative 4 out there, it's not going to be a real number. So you put parentheses around these. Anytime you have a fraction bar, you got parentheses around them. And then you're going to multiply by 4 plus I over 4 plus I. Remember, there's an understood 1 in front of this I. So A is 4, so we're going to have 4 squared, and B is 1 plus 1 squared. Now you do 5 times 4 is 20. 5 times I is plus 5I. 4I times 4 is 16I. And 4I times I is plus 4I squared. Okay, I'm going to combine my like terms, plus 21I, and then this is 4 times negative 1, and this is 16 plus 1. We have 17 in the denominator. This equals negative 4. So 20 minus 4 is 16 plus 21I over 17. Then we split that. Remember, we can split a fraction. We write it as 16 17ths plus 21I over 17. That's our standard form. Or we can write the I down here. You can write the I next to the fraction or up on the numerator. Okay, so that's your answer. So you have to memorize what a conjugate is. And you have to memorize or work enough problems so that you know the procedure for dividing two complex numbers. Any questions? Has your brain fried yet after taking the test and now having to... Yeah. Do you have a question?
Yeah. Is it going to be necessary on tests and quizzes to separate it, or can we keep everything over 17?
Oh yeah, I had the other class ask that question. I did not take off on, for instance, a worksheet I had the other class do if they left it all over 17. But I don't know if my stat labs ask or my math lab, do they?
They might ask for it fully simplified.
They might ask to have a blank plus blank I. Then you'll have to separate it in there.
Okay.
And so, I do have a worksheet I need to give you guys.
Homework?
Yeah. But it's like, where'd it go? Oh, here it is. This is your homework that's due next time. And we've already did problem 1, but with different numbers. Oh, you printed it out? Yeah. It's okay. We already did problem 1. Problem 2 is, do you remember how to use the quadratic formula? So you saw the filled in notes too, huh? Or did I just show that page? Do I only have just that page? Okay. Yeah, one day we didn't cover the quadratic formula in class one day, so I just scanned it. All right. For the online class, I'm actually scanning my notes and posting them because, but you know, it's not the same as watching, as seeing me do it. But sometimes integrity doesn't work, or it's too slow. Okay, the principal square root of a negative number. So for any positive number b, the principal square root of the negative number, negative b, is defined by, so if we have the square root of negative b, that's defined by I times the square root of b. Okay? So, we define that negative b as I times the square root of b. Remember when we were doing regular square roots, if you had the square root of b, it was just a positive number. But this is what we're going to do when we take the square root of a negative number. We replace that with I times the square root of b. Okay, so the product rule for radicals, that was, the product rule is square root of a times b equals the square root of a times the square root of b. It only applies to real numbers. Multiplying radicals is incorrect when you have two negative numbers. Two negative numbers. Okay, now I'm giving you an example when you have to watch out for this. When performing operations with square roots of negative numbers, begin by expressing all square roots in terms of I. So you're going to start on this, you're going to start by writing your square roots, then perform the indicated operation. So here's the correct way to do the square root of negative 81 times the square root of negative 4. You rewrite this as I times the square root of 81 times I times the square root of 4. Well, square root of 81 is just 9, so it's 9i times 2i, because square root of 4 is 2. 9 times 2 is 18, and I times I is I squared. But I squared equals negative 1, so you have 18 times negative 1, and the answer is negative 18. Okay. What you don't want to do is, I'll write this in red up here. This is incorrect. Is you don't want to write equals negative 81 times negative 4 inside the radical. And then you get the square root of 324. The two negative signs cancel out, and then you get plus or minus 18. See the difference? This is incorrect because when we take the square root of a positive number, you have to have plus or minus. The answer to this is just negative 18, not plus or minus 18. So it only has one answer. It's very similar, but because we got a positive square root under the radical here, we had to say, well, we could take negative 18 and square it and get 324, and we could take positive 18 and square it and get 324. So when you're working with these things, you're going to use this property right here and start by expressing all your square roots of the negative numbers as I times the square root of that number.
So would you say that that incorrect way might be a good way to see if we're on the right track with the answer? Like a check your answer kind of thing? Or no?
Well, if one of these answers was correct, so
Is it always going to be,
it's always going to be that way. It's
so they're always going to kind of equal each other, except for,
except you only
Plus
have
or
the
minus.
negative one. But
you just won't
no, I don't know. I don't know about checking your work with it. I have to do some more.
research.
Yeah, do some more problems, but I wouldn't want you to be writing your work like this to check it, because this is the way you need to do it. And remember, I squared is negative 1. Okay, so, I mean, you can skip some steps and write down that this is 9i times 2i and stuff, but, okay. The only time you worry about this is when you're multiplying those things. That's the only time this happens. If we're adding two things, okay, this is going to be I times the square root of 27 plus I times the square root of 48. That's our first step. You see a negative under the square root, just write I on the outside, square root of 27 plus I square root of 48. Okay, now we cannot combine these yet because they're not like radicals and like imaginary numbers. They have to have this, in order to combine like terms, you have to have I in them both here and the same exact radical. So let's see if we can simplify these square roots. So 27, the biggest perfect square that goes into 27 is what? 9. Okay, if you don't remember this, you can go onto your calculator and you can press y equals. And you can, if you don't remember what divides by 27, you can do 27 divided by x, and then press second table. So 1 times 27, 3 times 9. Ignore the decimals there, and 9 times 3. And then we can go all the way up to 27. So 9 is the biggest perfect square that goes into 27. So this is going to be I times the square root of 9 times 3. And we can separate these now like this. Because they're all positive, we can use this rule. And so that's 3i square root of 3. Because we went ahead and took the square root of 9 and got 3 and brought it out. Wrote it in front of the I. What's 48? Isn't that 16 and 3? Okay, so this is plus I square root of 16 times 3. Take the square root of 16, it's 4i square root of 3. Now we have like variables, the I, and we have like radicals. We can combine these. We have 3 plus 4 is 7. If one of these terms was missing an I, we couldn't combine those. If one of those terms had square root of 6, for instance, instead of square root of 3, we couldn't combine them. They had to have the same, they had to have the I and the square root of 3. If it had a cube root of 3, we couldn't combine them. Okay? It had to be square root, same radicals, like radicals. All right, the next one. So rewrite this right away as -2 plus I square root of 3. And we're going to FOIL that. So instead of writing squared, I wrote it again. Instead of squared. So you do -2 times -2. That's your first term. That's 4. Then you do the outer term. -2 times I square root of 3 is -2I square root of 3. Inner term is -2I square root of 3 again. Last term is plus I squared and square root of 3 squared. So we have like radicals, so this is 4 minus 4I square root of 3, and then this is -1 times, and square root of 3 times squared is 3. So that's -3. So 4 minus 3 is 1. And we have -4I square root of 3. And we want to write the I here when we have square roots in the thing, because if we write it as 1 minus 4 square root of 3, and then an I, we might think the I is underneath the square root. So we usually write the I at the end, but when it's a square root, so we don't think the I is under the radical, we'll write the I first, in front of the radical sign. I guess you could put parentheses around the other thing, but we'll write it like this instead. Okay? All right, and then this is dividing just by 2. So first we're going to rewrite. This is tiny on the paper. We're going to rewrite. This is -14 plus I square root of 12. And then we're going to divide each term by 2. That's -7. Okay, 12. The biggest perfect square that goes into 12 is 4. So square root of 12 is the square root of 4 times 3 is 2 square root of 3. So we have 2I square root of 3 over 2, and 2 divided by 2 is 1. So the answer is -7 plus I square root of 3. Okay, so if you don't remember how to reduce radicals, you gotta look back at that. We did some of that the very first day of class. Okay, and we went through this fast. You guys weren't slowing me down, were you? We're ready to get out of here. Okay. Do you have questions about what we just covered? I can slow down.
Did that last one just say -7 plus I?
Square root of 3.
Yeah. Okay. That's
Yes.
what I thought.
Uh-huh.
That's what I thought.
Yeah. I went fast, so. Okay, and this is the last page. Yay. So, review of quadratic equations. If you have a quadratic equation in its general form, that is ax squared plus bx plus c equals 0, make sure it has to be set to 0. And we would prefer to keep a positive. The other thing, it's better to keep a positive. We can solve it with it negative. but it just gets a little messy at the end. You're dealing with more negatives than you need to, but. So, in order to identify A, B, and C, you first have to make sure your quadratic equation is set to 0. And if A is negative, you could just simply multiply through by a -1 to change the sign of every term to keep it positive. So here's a quadratic formula. Minus b plus or minus the square root of b squared minus 4ac over 2a. So if this factors, this would be an easier way, but this doesn't factor. These things end up being complex numbers. We talk about the discriminant. This part inside the square root is called the discriminant. If the discriminant is negative, the quadratic equation has no real solutions. The solutions are imaginary numbers that are complex conjugates. Okay? So now we've covered quadratic formula in Math 1100, but when we got a negative number, we would just say, under the square root, we would just say no real answer. And we'd stop. Well, now you're going to have to keep going. So these are not factorable because these are going to end up being with complex numbers. So this is set to 0. So we identify what A, B, and C are. A is the number in front of the x squared term, that's 2. B is the number in front of x, that's -2. And C is a number, the constant is 1. Good math is you write your formula down and substitute carefully. Good algebra. Over 2a. So we have -2 plus or minus square root of -2 squared minus 4 times 2 times 1. All over 2a, which is 2 times 2. A is 2. Okay? And then that equals 2. And in here, we will have, and you can go off to the side and figure out the discriminant. You can even type that in your calculator and just give me what it equals. But it equals 4 minus 8. And all that's divided by 4, which is 2 plus or minus square root of -4 over 4. And that is 2 plus or minus I square root of 4. Okay, so it's 2 plus or minus 2I over 4. And then we can, if you end up with something like this, you can make a little heart if you want, or you can separate it out, but you can only divide something out of all. These are two different terms here. You can, if you can divide something out of all 3 of these numbers, the same number, you can do it. Otherwise, you can't. Or you separate it. Well, so this you can divide a 2 out of everything. So you get 1 plus or minus I over 2, or you could have separated, or if you separate it now, it's 1/2 plus or minus 1/2 I, or you could have separated. You could separate right here 2/4 plus or minus 2/4 I, and 2/4 simplifies to 1/2. So I guess you could have just separated it there if you didn't want to do the little heart thing, but they're separate terms. Now, that's your answers in my math lab. You will type them in as, you'll type them in as 1/2 plus 1/2 I, comma, and 1/2 minus 1/2 I. Now, it's going to be really, really tempting to say, well, a half plus a half is 1, so that's just I. You can't do it because they're not like terms. Don't do it. Don't do it. This is not equal to 1I. You cannot, they're not like terms. And this is not equal to 0. So this is, I just graded a test today in Math 1100 that did this. Just one person. Okay. So don't do that. They're not like terms, you can't combine them. Okay. So the answer was 1/2 plus or minus 1/2 I. Okay. And they didn't have I's on the test, so I don't know. They were doing stuff like that. So that's the quadratic formula. Now we're going to solve it for this using this one. These are already set to 0, but on your, you got to do 2 quadratic equations on the worksheet, and the second one's not set to 0, so you got to set it to 0 first. Okay. So A equals 3, because it's already set to 0, and B equals -4, and C equals 6. So X equals minus B plus or minus square root of B squared minus 4AC all over 2A. It's minus the -4 is 4 plus or minus square root minus 4 squared minus 4 times 3 times 6 all over 2 times 3. That's 4 plus or minus, and you could go off and do this off to the side, but 16 minus 72 all over 6 equals 4 plus or minus square root of -56 all over 6. 4 plus or minus I square root of 56 over 6. That's not your answer quite yet. You do have to simplify. 56. What is the biggest perfect square that goes into it? 4. 4 times 14 is 56. I don't have that memorized. I had it on my paper here. Sorry, you guys. If you can't, I know. If you can't remember your, no, you can just use the calculator. 56 divided by x. What are the perfect squares? 1, 4, you know, 1 squared is 1. Well, that doesn't help you on these. 2 squared is 4. 3 squared is 9. So you're looking for factors that, you could also take your calculator and do 56 divided by 4. And that's 14, and 14 is 2 times 7. That doesn't have any other perfect squares in it. So 4. You could do 56 divided by 9 and see if it comes out even. It doesn't. You could do 4 squared, 16. You could try 56 divided by 16. It's not going to work because there's no pairs here. Okay, so that's 4 plus or minus. So the square root of 56 is going to be the square root of 4 times 14 is 2 square root of 14. 2I square root of 14 divided by 6. Now I guess you may as well just separate this at this point. So this equals 4, 6 plus or minus 2, 6I square root of 14 equals 2/3 plus or minus I square root of 14 over 3 if you write it, I'm not going to count off if you write it as 2/3 plus or minus, let's see, square root of 14/3, and then put an I here. That's all right. I mean, I don't know if you can see that, but you can write it either way, but this is the way we prefer to put the I in front of the square root sign. Okay, do you remember your square roots, simplifying square roots? No? Okay, well, I don't know if the math lab will help you with that, or I bet I have some videos referenced on our D2L that go back to simplifying radicals. Remember I posted all those videos, so if you don't remember that, go back to simplifying radicals and look at that. I have a Haga notes that does this and talks about the perfect squares. He even has one for complex numbers, I think. I don't remember what I have out there, but remember it's under content, under prerequisite materials. So, right. He has videos out there that he shared with the rest of the department. Any questions? So the important thing is to set it to 0. So you guys, if you want, you can spend some time working on this and turn it in. 2.1 homework. But and if you're on the online class and listening to this, you should do this homework, but I'm not collecting it. But it's a good practice. And that's it. That's 2.1.